Hello and welcome back to this part 2, the triangle proofs cheat sheet. Wait, no that's not it. Unit 2, test 2, part 2. That's right. I'm going to do it in pen. Let's see what happens. Alright, this one was side, side, side. Because you have a pair of sides, a pair of sides, a pair of sides. This one was, well, some people are asking, like, how do you start it? Well, you just pick any feature, like this is a pair of sides here, and here, and then move around the triangle in either direction to the next closest feature. So we wouldn't go all the way around this way because we're missing that angle, we're missing that side, we're missing that angle. But if we go this other way, we know these angles match, we know these sides match. So you go around to the closest things. And in this case, side, angle, side is what we got, SAS. What about this? Well, this one's super tricky because if we start here, we're missing that angle, that angle. But then we'll hit this side. This is SSA, which doesn't work except they're 90 degrees. So we know the hypotenuse, we know a leg, we know the hypotenuse, we know a leg matches. And so we got hypotenuse, leg, hypotenuse, leg, HL. Let's try this one. Okay, don't start in the middle, start on the feature on the edge, angle, next closest side, angle. You have to make sure that everything matches, angle, side, angle, okay, 2 of everything in the same order. Now this one's difficult because if you start at this angle you have to jump over this side we don't know, but remember if you have 2 sides paired up and if you have 2 angles paired up and any side, it's going to work. The question is the side in between the 2 angles or is the side not in between the 2 angles? In this case, it's not in between them, so it's angle, angle side. It's just a slightly different logic step. I forgot these. Don't forget CPCTC. Corresponding parts of congruent triangles are congruent. Which, obviously, yes, but still this is a justification. If we were going to say, like, we know that these 2 sides are congruent. Well, how do we know that? Well, first we prove that the triangles are congruent using ASA, and then once the triangles are proven to be the same, now we can say these 2 sides match. And then if someone says, why can you say that? Then we say, because corresponding parts of congruent triangles are congruent. Duh. Alright, a quick reflexive property, AB, segment AB equals itself, or congruent to itself. M is the midpoint of segment AB, so it splits it in half, so AM is the same as BM or MB, doesn't matter which way you put it. Your choice. Segment KM bisects segment JL, so this is like the same. These are split in half, so segment JM equals segment ML. Vertical angles, 2 angles across from each other are congruent. So JKN is congruent to angle LKM. Or MKL. You can name it however you want. You can go MKL or LKM, same angle, 2 names. Angle bisector, segment BD bisects angle ABC. So then ABD is the same as CBD or DBC. You can name it either way. I'm going to go for the symmetry, CBD, because that's the definition of bisect. These italic words are like the justification. So we can say this. Why can we say that? Because that's the definition of bisect. We can say these 2 angles are congruent. Why can we say that? Because they're vertical angles. How about this one? This one's a little weird. If you wrote congruent here, that's fine. But what they were going for was the fact that they're perpendicular lets us say that both angles are right angles, because that's the definition of perpendicular. But if they're both right angles, then they are congruent to each other. That's why it's okay if you wrote congruent there, because they are. ADB, CDB, because all right triangles are congruent. That was a 2-step thing. I don't know why. And then I did this one, because we haven't talked about alternate interior angles. That's next unit. What is this sheet? I didn't want to white out the whole thing. ABC, EFD. Are they? Well, yeah, this is side. One of I look at these and I just assume that the two triangles are the triangles, right? But one of them actually is named incorrectly. Really sharp student, notice that. Okay, we got pair of sides, and then shared side in the middle. So this is reflexive property. CA is congruent to itself. That's another side. Here we have pair of sides, pair of angles, pair of sides. Is this the one? A, B. Yeah, this is the one that's named wrong. AB goes along the 1 mark, but then EF goes along the 2 mark. So technically they screwed this up. That's all right. Typos, I'm sure. Ooh, 90-degree boxes. So, do we know the hypotenuse? Yes. Do we know a shared leg? Yes. Hypotenuses match. We got the 90, this hypotenuse leg. This one, it's 90s, and we know the hypotenuse, and we don't know the leg. There's no leg information. Although, interestingly, if this line is straight, and these are 90s, you might be able to make an argument. Because the only way that these two triangles aren't congruent is if this line is secretly crooked. I believe. Yeah, because then, or if these don't meet here. Oh no, I'm wrong. It could be like this. One could be like this, and then one could be like this. As long as these are the same length. Yeah, so they don't have to be congruent triangles at all. Sorry, don't listen to me. Now, we have some vertical angles here, which makes that pair of sides, pair of angles, pair of sides, and shared side in the middle. So reflexive property, we get a pair of sides there. And then a few people are confused about these angle marks. And this is my fault for not explaining this. For an angle mark, what matters is how many there are, kind of like the side marks. But the side marks end up looking very similar. The angle marks end up looking weird, but as long as there's one mark, that's a matchy angle. And it has to do with the fact that if you have multiple angles in the same spot, you don't want to just like make them exactly the same, because then it looks like one big angle. So you have to offset them like this. Like there's those both have 2 marks, but they look different, but they're the same. Three sides, the shared side, and side, angle, side. Side, angle, side. And they even marked the vertical angle for us. Thanks. Thanks, dudes. Should we go over here? Angle, side, angle. Yeah, there's those funky angle marks, but there's 2, so they match. Okay, 90 degrees. Do we have the hypotenuse? Yes, they match. Do we have a leg? Yes, hypotenuse, leg. This one's weird, but this whole side is made up of 4 and 1 marks. This whole side is made up of 4 and 1 marks. So that side matches. These sides already match. And then this side is made of 2 marks and this overlap section, 2 marks and the overlap. And the overlap is equal to itself, reflexive property. So this is our good old friend side. 2 angles and a side. Side's not in between though. There's actually extra information here because we have this secret side and we have 2 angles. Well, if we have 2 angles, it's going to work, but we don't have the side in between. So no matter how you slice it, this is going to be angle, side. This one has an extra piece of information that this BD ray bisects this angle, making 2 equal smaller angles, splitting it into 2 equal angles. So the shared side split angles, side. Nineties, hypotenuses, and a shared leg. So we got a hypotenuse leg. Okay. Triangle DEF matches YXZ. They want to know segment EF. Well, segment EF would match with XZ. In the triangles that are congruent LMN and PQR, what angle would be congruent to M? Whatever corresponds with them, namely angle qua. Z, F, G, H. They want to know what's the F. What the F mean? And in triangle STU and triangle XYZ, what it goes with segment T. Not too bad. These triangles are completely congruent. It goes with Q, angle U. A, B goes with E, D. Segment Hawaii goes with, well, let's see here. FE. I mean, again, if you're just talking about a segment, you actually can name it either direction because a segment has no width, it has no orientation. So FE is the same as EF. However, since it is part of a larger structure that is orientable, it is good practice to try to name it in the same order. So I went from single mark angle to double mark angle. So over here, single mark angle to double mark angle. Angle X, angle P. And then they give us the challenge question. Triangles QRS is congruent to triangle BCD. What corresponds with the part segment SQ. And the funny thing about that is it's a wraparound. So from S to Q is D to B. Alright, cool. Make sure to get your reviews uploaded by tonight for the test tomorrow. Bye.